Hello, I'm Dave Kapczarowski and welcome to Dave's Corner. This is a continuing series of our technical lectures that deal with radon mitigation design. Our session today deals with system piping design. When designing a radon mitigation system for a typical residential situation, we're dealing with typically airflows from the fan system of 20 to 80 cubic feet per minute. We may use between 20 and 40 feet of pipe, and typically somewhere between 2 or 4 bend fittings. The question that we're asking here today is system performance and how it's affected by your piping design. And is there a significant difference between 3-inch pipe and 4-inch pipe when used in a residential system? One of the methods for determining system pressure loss is called equivalent length method. Now, equivalent length essentially takes a fitting, as we see here. This is a 3-inch 90-degree elbow. And what we're going to do is straighten this out. And as you can see on the chart, a 3-inch 90-degree elbow is the straight equivalent of 2 feet of 3-inch pipe. Similarly, if we were talking about a 4-inch 90-degree elbow, that would have an equivalent length of 3 feet. So what we will do in calculating the system pressure loss is to take the bend fittings that are typically used and determine the equivalent length of those, add that together with our straight pipe, and then on the basis of that, we can then determine what the overall pressure loss is within the system. Here is a typical residential ASD system. It's an outdoor installation, and it uses a minimum of 20 feet of straight pipe, which is 8 feet for the riser in the basement. It goes to a 90-degree fitting to exit through the band joist, another 90-degree fitting on which we mount the fan, and then 2 45-degree bend fittings that will get the pipe back along the wall and 12 feet to get above the roof. So let's use our equivalent length method to determine how much pipe is actually used in this type of system. Now we can see here in the chart, again, if we're talking about 3-inch pipe, the equivalent length of the 3-inch pipe is 2 feet of straight pipe. So in this example, we have 2 90-degree elbows, which is the equivalent of 2 times 2 feet. We have 2 45-degree elbows, which are the equivalent of 1 foot each. And so if we add those equivalent lengths to the straight pipe of 12 feet and 8 feet, we find our total equivalent length to be 26 feet. And similarly, and you can see in the chart, we can also do this for 4-inch pipe. Calculating the equivalent length of this system in 4-inch pipe, we come up with a total of 29 feet of length. Once we've determined the equivalent length of the system, we can now take a look at what the pressure loss is inside various types of pipe at different airflows. And from this, we can build a chart which will allow us to then answer that question. Is there a significant pressure difference or pressure performance difference between 3-inch and 4-inch pipe? Turning to our pressure loss chart, in this example, we're going to take a look at determining the pressure loss associated with 3-inch pipe at 25 cubic feet per minute. And so along the x-axis, we follow along to the point where we see 25 cubic feet per minute. And from there, we trace up until we hit the diagonal line. In this case, we're looking at 3-inch pipe. So once we hit the 3-inch diagonal line, we then follow that over to the y-axis. And we see here in this example that 3-inch pipe at 25 cubic feet per minute will generate a 0.2-inch water column per 100 feet of pipe. 100 feet of pipe is not typically what we use in a residential system. You may encounter that if you were doing a school or a large commercial building. But residentially, we deal with much smaller lengths of pipe. And so what we need to do is to take, from our example, for 3-inch pipe, we used 26 feet was the equivalent length that we determined from our equivalent length method. And so multiplying that ratio of 26 divided by 100 times 0.2 inches of water column that we got from our chart shows us that at 25 cubic feet per minute, this system will have a pipe loss of 0.052 inches water column. And so we can then take that information and look at various other airflows, in this case within the range of 20 to 80 cubic feet per minute, which is really where residentially where radon systems operate. And so we'll look at 50 cubic feet per minute, and again using the same method of following along the x-axis until you hit 50 cubic feet per minute. Follow that up to the diagonal line for 3-inch pipe, and then trace that over to the pressure loss on the y-axis, and multiplying it by that ratio of 26 divided by 100, we can fill in the various values for airflow for 3-inch pipe. And so we see here that at 50 cubic feet per minute, the air loss for our system, in our example, is 0.19 inches of water column. And at 75 cubic feet per minute, the total pressure loss is 0.4 inches water column. Again, using the same 25 cubic feet per minute, follow along the x-axis till you reach 25 cubic feet per minute. Follow that up to the diagonal line for 4-inch pipe. And then trace that over to the y-axis. And there we find that at 25 cubic feet per minute, 4-inch pipe has a total pressure loss of 0.015 inches of water column. We fill in for the remaining values. At 50 cubic feet per minute is 0.055 inches water column. And finally, at 75 cubic feet per minute, we see that 4-inch pipe in our equivalent length of 29 feet has a total system pressure loss of 0.11 inches water column. So in our comparison here, at 75 cubic feet per minute, we see that 3-inch pipe will have a total system pressure loss of 0.4 inches water column. And for 4-inch pipe, the total system pressure loss is 0.11 inch water column. Now the fans that we typically use, if you use an RP145 or an XP201 fan, those fans have a 2-inch water column total pressure. Something like a GP501 has a 4.2-inch water column pressure. So we can see here that the difference between 3-inch and 4-inch pipe actually represents a small percentage of the overall pressure performance of radon-away fans. And so from that perspective, we can see that from performance perspective, that 4-inch pipe does not offer a significant advantage over 3-inch pipe. 3-inch pipe, however, is less costly. It's easier to work with. It's not as heavy, and it is easier to hide, and it's less obtrusive. Now, when should you consider using 4-inch pipe? Anytime where you have a system where you expect the airflows to be greater than 100 cubic feet per minute, then 4-inch pipe is definitely called for. When might those situations arise in a residential mitigation system? If you have a walkout basement because the foundation footer is buried less deep than it would be in a fully buried basement, they tend to have more airflow leakage around the foundation. So your airflows, and consequently your driving forces, which might be caused by the wind underneath the slab, require that you move larger volumes of air than you typically would in a residential situation. Similarly, if you have a submembrane system or a combined submembrane and subslab system, submembrane systems tend to leak more air than a subslab system, and so your airflows on a combined system like that might exceed 100 cubic feet per minute. And consequently, if you have a very large slab, there again, your airflows might exceed that 100 cubic feet per minute. And so you should take that into consideration when doing your design. If you were to design a system with 3-inch pipe and end up with the need to move more than 100 cubic feet per minute, you could actually find yourself in the situation of having to tear out the 3-inch pipe to install 4-inch pipe just so that you could get adequate airflow through the system. With 3-inch pipe, airflows above 75 cubic feet per minute are simply not possible with the kinds of fans that we typically use in radon systems. And so you get into a situation where you're pipe bound, and it's impossible to move additional air. And that doesn't even begin to address noise issues because of the increased air velocity, which you would experience in 3-inch pipe trying to move those values of airflow. So overall, I think we found that 3-inch and 4-inch pipe, no significant advantage to 4-inch pipe unless you have large airflows, and so take that into account when you're designing your system. And we'll use that information later on as we look at overall system performance in fan selection and also in system operating point. The determination that the information that we've determined here will be used as a building block for your overall system design.